What is up, MCAT people? Today's question is something that I personally think, when I came up with I thought it was a really good question because it's something that I myself have heard my doctor talk to me about, and I think it's very medically pertinent. So today's question says the chart below shows the intracellular and extracellular concentrations of common ions within and outside of human cells. Based on this information, a 1 millimolar fluctuation in which of the following ion concentrations is likely to have the most significant effect on human physiology? And by the way, in this chart, you'll see the units being MEQ. MEQ is basically the same thing as millimolar. It's just that because I found this chart online, they use MEQ. Well, nevertheless, I want to know like intracellular chloride, intracellular potassium, extracellular sodium, or intracellular sodium. If you now take all of these ions and you go back to the tables, and you have a fluctuation of 1 or 2 millimolars above the standard range, which one is going to be the most significant? That's my question to you. And for this problem, we're going to neglect the A, which is anions, because we don't need to worry about them yet. But just know that the three that we are worried about are sodium, potassium, and chlorine. Okay, so now let's go on. So the way you want to approach this question is you want to think about it in terms of percent change, because all of these values are different. So the only way to standardize amongst them is by using a percent. You want to know how much is 1 millimolar in contrast to how much is actually present. So now let's start with our first answer choice. Our first answer choice says intracellular chloride concentration. So if we were to change the intracellular chloride concentration by 1 millimolar, that would basically be like taking the 9 millimolar that we know is inside of the cell, right? And then making it 10 millimolar. So the way you do percent change is basically, percent change is usually the uh, change you make. In this case, the change we make is 1 over the original, right? Original value. So in this case, if we had a 1 millimolar change, that would be 1 over 9 millimolars because we're changing 1 millimolar, but the initial concentration inside is 9 millimolar. So the total change there is 11%, right? Because 1 over 9 is 11%. So that would be an 11% change. That's pretty significant, but to answer this question, we have to find the one that is the most significant. So moving on, the next ion we want to analyze is potassium, intracellular potassium. And you'll see that intracellular potassium is usually around 150. But now let's say it changed by 1 millimolar. So instead of 150, let's say it was 151. Then the percent change would literally be the, oh, well, I wrote 150, but I meant 151. Then the percent change would be the change, right? The change, which was 1 millimolar, over the original. And the original was 150, right? And if you do 1 over 150, you'll get about 0.66%, okay? And that's actually pretty insignificant because the intracellular potassium level, as you already know, because of the sodium potassium pump, is already really high. So adding 1 millimolar there is not really going to change anything in the cell. It's pretty insignificant. But now, let's say we move on to extracellular potassium, right? And that would mean like the extracellular potassium is 5.5, and that would mean we change it to 6.5, right? That is insane, okay? And for our purposes, 1 over 5.5, I think I can just pretty much round this to, I guess, 1 over 5 if you want to, not do intensive math. And in this case, the change is literally 20%, okay? The percent change is 20% because you're adding 1 millimolar, but we only had 5 to start with. So if you change outside by 1 millimolar, you're almost changing it by close to 20%, which is really, really significant. The extracellular potassium is very sensitive to change, right? So now let's move on. The next one would be extracellular sodium. The extracellular sodium concentration is again 150. So, if we start with 150, which is our initial, and we change it by 1 millimolar, we'd be at 151. So the percent change here too is 1 over 150, and that's around 0.66%. And again, I told you, it's really not that big of a deal because the sodium potassium pump is always pumping sodium to the outside. So changing it by 1 millimolar is really not really even that big of a deal. Last but not least, we're going to hit the intracellular sodium. So the intracellular sodium, we're going to add 1 millimolar to it. And remember, the initial is 15, right? The initial is 15, and we're changing it to 16. We're going to change it by 1 millimolar. So the overall percent change is going to be the amount we changed it by, which is 1, over the initial value, which is 15. And 1 over 15 if you don't already know, you should be able to kind of guesstimate. But it's about 6.6% because it's 10 times the 1 over 150. But again, if you didn't exactly know, you should know that 1 over 15 is still less than 1 over 10, which is less than 10%. So now if we wanted to go ahead and write all of these down in one place, right? Um, Recall that the change in intracellular chlorine when we started was 11%. The change in intracellular potassium, if it were to change by 101 millimolar, was 0.66%. The change in extracellular potassium was 20%. The change in extracellular sodium was 0.66%. And the change in intracellular sodium was 6.6%, right? So the point here is that the one that is the most significant, right here, look at that, 20%. A 1 millimolar change in potassium, the extracellular potassium, is 20%. A 20% change. Just by changing your extracellular potassium by 1 millimolar, you'd be changing the entire equilibrium by 20%, which is insanely substantial. And that's a big, big, big deal. All right. You'll see on this slide where I've actually highlighted everything, you'll see that a small change is most important and most impactful for extracellular potassium. And that's a big deal because if you're in the doctor's office, you might realize that the number one thing they might check sometimes is your potassium levels, because your potassium levels are supposed to be very controlled at all times because there's not a lot of potassium outside of your cells. And so if that changes by even a bit, that can be detrimental. And they have terms for this. They have terms which are known as hypokalemia and hyperkalemia. So in this case, if your potassium levels dip by even 1 or even 2 millimolars, you're known as hypokalemic. And that's because your potassium levels are very low compared to what they're supposed to be. They're literally only 2 millimolars lower, but that's already substantial enough to be bad. Okay. Similarly, even the slightest change can be fatal in the opposite direction. So if you have too much, hyperkalemia is also a thing. Hyperkalemic is when you have too much sodium, and that's more than 7 millimolar. So you'll see that small changes in potassium are huge. All right, and that's why extracellular potassium is most likely to have this most significant changes on human physiology because it's tightly regulated, and that's why there's only 5 millimolars at all times. And if that gets too high or too low, you can have pathological conditions. So with that, I hope you guys enjoyed the video. I'll see you in the next one. Like, comment, and subscribe, and thanks for watching.
Hey, thanks for watching the video. Really appreciate it. You want to check out any of my other videos, there's going to be one right here. Another link to one of my videos right here. And another video right here. Why not? I'll put one video right over here. And last but not least, if you want to subscribe to this channel, really appreciate it because I'm still an early YouTuber trying to get it down. But a subscription button should be right over here. So please subscribe. Cool. Thanks. See you guys in the next one. Hope you find these videos helpful.